Okay, here's another in the never-ending permit sheets. This is the electrical plan. I'm pretty sure this is my original plan, not the one that they redid for me, which you can't tell it apart. They changed a couple of things in the calculation. I'm not sure how they did that because it was a print. You really can't erase things out of a print. Not a CAD drawing. I can erase everything and change it, and you can't tell it's ever been changed because I got the original file. But what they had was a blueprint, a paper blueprint. But they managed to change, or they tell me they changed it. I never really looked. Anyway, on the top, it's a calculations like spreadsheet. On the bottom left, it's the floor plan of your house and how the receptacles are run. They're basically the daisy chained. Some of the lights have to have a switch. Some may or may not be daisy chained. How you get from a particular thing, the path back to the circuit breaker box. It's pretty much so the electrician, like, that show up? Yes, it shows up. Like here you have a hole in the wall. There's no reason not to have receptacles on both sides of that wall. I mean, it's just a matter of drilling a hole through the wall or cast, in our case we have cast concrete. So we just put a block in either side and then knocked it out with a electric chisel. But that puts a receptacle in this room off a sun breaker, as well as this one over here, so off a sun breaker. The next room, you have that breaker and the breaker for this room on the other receptacle. So every room basically has two sources of receptacle electricity. Oh, this floor plan is not exactly what we ended up with. It's got this hall in it. And we had to, the hall was 3 inches too narrow for the fire department. So we just basically moved this wall over to there and did away with this wall. It's one big open room now, just pretty much like these. This was the pantry. This is still the kitchen. And what we did is we made this whole segment. We did away with that hall. See, the halls were for, in my opinion, they were drawn in there for fire egress. Any room in the house dumped into the atrium. And from the atrium, you had a hall down here and right to an outside door. Outside door here, outside door there, outside door down here someplace. Anyway, they didn't like that. They didn't like the width of the halls. And then there was only one means of egress from a room, like here. You have a door coming out of that room, but they all go to a common place. And if that's where you're getting smoke, if somebody lights up a couch in there, then you have to go stand by the window until the smoke clears. Anyway, we're looking at electrical. See, I can. Yeah. Windows reinstalled or installed some updates. Though I had updates turned off, they decided to change something, and I've lost my toolbar up here that has the pan and zoom and all those kinds of functions. I'm gonna have to reinstall Rhino tonight. This is a key, and it shows you what all the little symbols over here. See this that's like 4 lights on a ceiling fan kind of deal, hang off the bottom. Anyway, there's 4 bulbs in that. And if you look at this symbol, it tells you that's a chandelier. So it's a light in the middle of a room. This list is pretty much a standard list. Here it says this kind of outlet is air conditioning outlet, grounding type, automatic reset. We don't have air conditioning. But just so that anybody that adds something to your print has got a symbol, and the symbol will match up to your other prints, you just put the whole block of symbols in the drawing and use the ones that you put in here. Oh, there's another little interesting thing. This house was drawn up to be built out of concrete blocks, which let us count the number of blocks. And all the bond on the blocks has to come out to the door openings and things like that. Oh, also, our columns are different than they do here. These are like 30 by 35, 30 this way and 35 that long, or 28 this way, 35 that long, and this is shorter. You got a notch here in the side of the column, 3 places, and that's to anchor the walls. Rather than trying to drill and put a piece of rebar in here and tie it to the rebars in that you bend over into the blocks and stuff, we just did it that way. This column and this column use the exact same form to make them, because when the panel for the form is pretty much straight across here, that makes this panel and that panel the same length, because they're going between the other 2 panels. So that lets you just turn it around and put this one over here and this one over there, and that goes from this to that. So we made 10 of these, and then we come back and flipped them. Just put them together. You know, we have to take them apart to get them off and put them back together. So we flipped them and made the inner ones out of the same form. And when we went to poured concrete construction, we only needed enough forms to do a spoke or to do an outside wall. And then we used them 36 times. They're substantial forms. It's still easier to use a toolbar. I wish that update hadn't done away with it. Well, let's go bigger right off rather than having to change it. Okay. This house is showing 26 circuit breakers, 26 individual circuits. That should be 1-6. I don't, yeah, nobody's perfect. You have the number of the circuit, that's the breaker that it goes to in the breaker panel. The description of what you're feeding off of it. The number of outlets for various kitchen appliances. That's the stuff that sits on the counter, but not the refrigerator. See, refrigerator and dishwasher and all that, they'll have their own, because it might be a different amp circuit breaker. Like you might need a 30 on a or 40 even on a dishwasher. A refrigerator is only like 6 amps, so it would be on a 15. And also, you notice that there's only one item on 1-3 is the refrigerator. It's got its own breaker. So we got number of outlets. If you're using LED bulbs, like whatever that was, it's got 8 bulbs. They're 4 watts apiece. Sounds ludicrous to be talking about a 4-watt light bulb. The light bulb in a U.S. refrigerator is 15 watts. A Christmas tree light bulb is 15 watts. But a 4-watt LED, our ceiling fans in the house we stay in had I guess you call them receptacles. What do you call a light fixture? Held 4 bulbs. We put 4 4-watt bulbs in it. It was unpleasantly bright in here. So we took 2 of them out, and we left 2 that pointed towards something we wanted more light on in the room. But now we got these empty things in the fixture. But in retrospect, we should have had 6-watt bulbs. And if we ever have to replace one of them, we'll put 6 watts in about half the ones in this house. And we'll probably, I only priced 6 watts, 192 pesos, and 9 watts, it's 220 some pesos at Wilcon. this would have been a single click, except that Windows has changed my mess. For instance here, 8 bulbs times 4 watts each, that's 32 watts. If you divide the 220 volts by 32, you end up with the amps. Now you notice that we're using 0.145, less than 2 amps for 8 bulbs. Okay, less than 2. This 2 would be, the number would be on the other side of the decimal point if it was 1 point something. But this is 0.145 amps. Smallest breaker they sell in the Philippines that we can determine, I mean house type breaker, is 15. So we can't put wire downstream of the breaker that's not able to support the amps that the breaker would send through it. So we have to use number 14 wire, which carries 15 amps, nominal is 15. We have 15 amp capability and 0.145 actual amps. The wire's 10 times bigger and also many times more expensive. But available, you can get it anywhere. So that's just one, look at this one. 1/100th of an amp. Oh, well, actually almost 2. We'll call that 2/100th of an amp. It's on a 15 amp breaker. Only in the Philippines. More fun in the Philippines. It is more.